Hello, this is Unit 7.4, Algebra 2. How do we solve exponential and logarithmic equations? The property of equality is this. If a log base b x equals log base b y, if and only if x and y are equal. So when you have the same base and these values are here, those values have to equal one another. That's an important property. So look what we're going to do here. We have we have a 2 to the x minus 3 equals 85. Well, you know that you can't reduce this into a 2 to some power and solve it that way. So the easiest thing to do is to bring in your logs. And now you've got log 2 to the x minus 3. Now we go to the property of logs. When we have this exponent, we can bring it out front. That was our power property. So x minus 3 log 2 equals log 85. Now we're trying to get this x term alone. So we see it's being multiplied here, going up our PIMDAs. We would divide by log 2. What you do to one side, you do to the other. This will cancel. We have x minus 3 equals log 85 over log 2, or divided by log 2. Last thing we need to do is add 3 to each side, so we get x equals, just to shorten time, I'm just going to add 3 to each side, so that would wipe that out. We'd have plus 3. Punch that into a calculator. Please grab one off my cart. It should come out to be about 9.409, something like that. But punch it in there. Actually put this in parentheses so that you're sure to have the order of operations. And so you go log 85 divided by log 2. You may even want, I don't know if you'll need parentheses around each of those C, if it makes a difference. And then when you get that answer, then you add the 3 to it. If you put it in with the parentheses, you can add the 3 right there on the first screen. Okay? But it comes out as 9.409, and that's why you couldn't have done it using the exponents. Here's a real-world problem. Adam has $500 to invest for 4 years. He wants to double his money. What interest rate does he need? Assume that there's continuously compounded interest. So we're back with the APERT equation that we worked in the exponents unit. Because we've got continuous interest. He's going to try to double his money, so we need $1,000. He starts with 500, e to the 4r, because it's 4 years. So we divide by 500 on each side. We get 2 equals e to the 4r. Now we bring in our LEN, which is, remember, LEN is log to the base e. So that should make sense. When we bring in the LEN, we bring it to each side, and then we apply the property of exponents. So raised to the 4r, just like the last problem, we bring the 4r to the front. But now, as you look at this, LENE means log e base e. So anytime you have LENE, it's going to cancel because log base e to the e equals 1. So you can cancel it and put a 1, or you can just say 1 times anything is that. Okay, so our last thing that we need to do to find the rate is, sorry, I just want to make sure you're able to see it. Divide by 4 on each side. That will cancel. This will be our rate. Plug that into a calculator. LEN2, there is a button for LEN. LEN2 divided by 4, and you should come out with about 17.3% is what he's got to get for his interest rate. Kind of hard to find that. Okay? So now we go into logs to solve these. And I've had students tell me how they got them really easy, and I'm going to show you their shortcut. If you have this problem, log 3, x plus 1 equals 2. The student said they switched it to an exponential equation. They just went base 3, and then they did the inverse. They put the amount over here, that y value over here on the exponent, and they took the x value and put it over here. I have not seen that taught so easy in a math book, so I'm just telling you from former students it does work, and they seem to get it really well. So now we just go ahead and finish 9 equals x plus 1, subtract 1 from each side, and we get 8 equals x. I really think you guys will enjoy these problems just because they just kind of tickle your brain, making you think it backwards and different things. So the first step on this one is to get the log by itself. So I subtracted 7 from each side. Let me switch my pen color here. I subtracted 7 from each side just to get us started. We get log 3, 5x minus 4 equals 3. Now don't forget, minus means that, actually, on this one, yeah, I would just switch it to the exponential. 3 raised to the 3 equals 5x minus 4. Sorry about that. I was just thinking of another direction you could go with it. But this is a much better one. 9 equals 5x. We would add 4 to each side. And we would get 14. Divide by 5 on each side. And we would get x equals about 2.8. Something like that. Okay. Make sure to come to class with questions. For what limited magnitude do these two formulas for a telescope lens have equal diameter? Here's how I'd solve this kind of problem. Is to give you the function rules for each of the diameters. I would plug it into a graphing calculator. y1, I would put it as 2.7 plus 5 log x. For y2, this is up in the graphing feature, I would do 4.5 plus 4.4 log x. And then set your window at x between 0 and 2000, y between 0 and 20. Do a scale of 1 to 5, and then hit second trace, which will get you to the calculator, and go number 5. And it will tell you right where they intersect, and that tells you for what diameter to have equal amounts. Okay, try that out. Come to class with your questions on it.